Hi, I'm Peter from Neoden USA. A number of our customers have asked us to describe just the basics of the reflow process so they can understand how to get the best results out of our machines or any reflow ovens that they might be using. So we decided to put this video together to give you an idea of what to look out for and how to refine your techniques to get your reflow process as good as it can possibly be. Basic understanding of the principles involved ought to help with that. Why do they call it reflow? Isn't it just flow? The idea is that the first flow happens when the solder paste is pressed through the stencil onto the board, and the tackiness of the solder paste holds your components on there until you put the board in the oven. When the solder is heated, it's considered reflowing the solder in the same place to now hold the parts permanently in place. Sounds simple enough, but there's plenty of details about solder paste, heating, and just the techniques of applying the solder paste that can really up your game when it comes to getting predictable yields on reflow operations. So let's start with the idea of solder paste itself. It's a fairly mundane little jar of gray goo, but solder paste is actually a very complex substance. One of the reasons it costs so much. The paste consists of tiny balls of solder that are sized based on the T number in the part. So if you have a T3 solder paste, it's going to have bigger balls than if you have a T4 or a T5 solder paste. In general, for the type of work that you're going to be doing in a small manufacturing operation, unless you're making wearable devices, a T3 or a T4 paste is probably going to give you the best results in terms of flow through the stencil and also the ability of the balls to resist oxidation that could prevent the formation of a good joint. These little tiny balls are suspended in flux paste, and that paste has to be activated. That's part of what we'll talk about in the reflow profile in the oven. It's absolutely critical, as you'll see in these pictures, that you use fresh paste that's been properly refrigerated and then properly brought up to room temperature. Old solder paste is your enemy. It will be dry, it will not hold your parts in the right place before it goes in the oven, and while you may get a joint out of it, that joint is far less reliable than a joint made with fresh solder paste. There are three basic steps to a reflow profile. The first step is called the preheat phase, and as you might imagine, the purpose of that is to heat the entire board to a temperature near where the paste wants to be, because the board acts as a heat sink. All that copper on the board will absorb heat, and it will do so according to the way your board is laid out. If you have ground planes or you're using a multi-layer board with power planes sandwiched in between, all of those planes will absorb heat and change the overall temperature profile of the board in ways that are somewhat unpredictable because all boards are different. The idea of the preheat phase is to get all of those sections of the board up to a uniform temperature so that the solder paste can react appropriately when additional heat is applied. So the first part of the reflow profile that you'll see in either a solder paste data sheet or component data sheets has a slow ramp up to a steady temperature, and that's why we do that. It's important not to ramp that temperature up too quickly. What that will do is effectively boil the flux rather than activate the flux, and when the flux boils, the little balls of solder inside fly off, giving you little balls of solder on your board, which could cause all sorts of problems when it comes time to test the board. So we try for a 3 degrees centigrade per second ramp up rate to the preheat temperature. The next section of a profile is called the soak phase, and this is done at a higher temperature. We'll discuss the temperatures you're most likely to see soon, but this is done at a higher temperature, and this is when the flux paste really gets activated and the solder paste as a whole stabilizes into a solid gray film with the parts still affixed. As the flux gets activated, it starts to convert organic compounds that might be on the pads or the components into substances that can vaporize away, leaving a nice clean metal-to-metal bond between the pad, the paste, and the component. The third phase is called the reflow phase, and that's the point at which we bring the paste up to a liquid state and hold it there long enough to form a reliable bond between the paste, the pads, and all of the components. That's the hottest phase of the profile, and it's the most critical to avoid overheating because that's the point at which your components are very near their tolerance for abuse from heat. We try to keep that temperature always below 250 degrees C, and we'll discuss exactly how to set that in a moment. And the fourth and final phase is the cooling phase. It's less critical how quickly this cooling phase occurs, but we try for about 4 degrees Celsius per second to cool the board down to a temperature where you can actually touch it. It'll still be hot, but you can touch it. And at that point, hopefully you have a working board. You might look at the data sheet and think that setting a reflow profile is as simple as picking the temperature points identified on the curve and setting them in your oven. Unfortunately, life isn't that simple. We need to bring a circuit board that has copper patterns on it up to the temperature specified, not the air around the board. So that requires that the air around the board be a little bit hotter and that the board travel through that air at a certain rate to make sure that by the time it enters the next phase, it has reached that temperature. How do we know how hot to actually set the oven to achieve that effect on the board? The best way is to use a thermal probe taped to the board with Kapton tape, and we'll demonstrate here on one of our ovens how to graph that profile to get it as close as possible to the manufacturer's datasheet. Getting the profile as close to the manufacturer's datasheet as possible is actually much easier when you use a conveyor-style oven over a drawer-style oven. The problem with a drawer-style oven, no matter how good it is that the thermal mass of the board can only change so quickly. And when the board is sitting in one place, you're asking a lot of an oven to raise and lower temperatures very, very quickly without causing other problems such as uneven heating or cracked components. A conveyor oven solves this problem by physically moving the board into zones that are already the temperature that we want them to be and circulating gas around the board to make sure that you get a nice, even heat. Obviously, the first step in the process is to apply the paste to the board through a stencil. It's critical that the stencil be very clean on the top and the bottom, and normally we use isopropyl alcohol to clean the stencil to make sure that it's ready to pass all the paste through small holes and that it's ready to do so evenly. If the board doesn't sit parallel underneath the stencil, you're going to have parts of the board that have too much solder and parts that have too little. Too little solder, the problems are obvious. You may not get a good bond between your component and the board. Too much solder can also be a problem because you can wind up with spattering or you can wind up with components floating on top of the solder but not forming a good electrical connection. So it's important that our final board look more like this image than that image. Let's take a look at what happens when the oven is set so that the reflow segment of the profile isn't quite hot enough. And now let's take a look at what happens when the reflow section of the profile is set too hot. The effects are immediately obvious. Also, of course, when the reflow profile is set too hot, you may find that you have decent-looking solder joints that affix broken components to your boards, and we want to avoid that. So it's important to keep the temperature on the board just right.